Yes, in this video we are going to discuss about Tdma. So basically, NA-Tdma architecture is similar to GSM architecture, but the only difference between the Tdma and GSM is nothing but one common interface, which is the radio interface. The NA-Tdma uses the intelligent network. All the components such as HLR, already we have discussed in the previous video, home location register, VLR, AUC, EIR are the same as used in GSM. So all these things will be used in both GSM and as well as NA-Tdma. And in NA-Tdma system, we're going to have two phases. In first phase, uh, to commonly share the 21 setup channels that are used for the analog system. That means 21 setup channels are used for analog systems especially. The first phase system is only for voice transmission. Both modes amps, AMPS and distal are built in the same unit. The handoff procedures has to take care of the following four features. That means in the first one, amps to amps. That means so from analog to analog, it has to handoff procedure has to take care of both analog to analog and distal to distal and analog to distal and distal to analog also. That's we can name it as an amps to amps, TDMA to TDMA, that we call as distal to distal, and amps to TDMA, that's what we call as analog to distal, and distal to analog, that means TDMA to amps. So all that things has to take care in the first phase. But in the second phase, generate new distal setup channels to access TDMA voice channels so that a distal standalone unit can be provided, and it also specify a data service signal protocol for transmitting data. So what you're looking at is nothing but your TDMA architecture, which you can see the having the same features as in GSM. But as you can observe here, MS2BS, there is a common interface between these two. So that is the only difference between the NA and TDMA and GSM. So now we are going to look at the signaling format in different channels. Basically, in this TDMA, we're going to have a reverse digital traffic channel, which is used to transport user information and signaling. Whereas another traffic channel is there, is nothing but forward digital traffic channel, has same format as RDTC. RDTC is nothing but reverse digital traffic channel, what we discussed earlier. And this is two control channels are used. The FACCH is a blank and the burst channel. The SACCH is a continuous channel and interleaving is on the SACCH. Means FACCH is a blank and burst channel and SACCH is a continuous and interleaving one. And the signaling formats will be as you can see here. Yes, so this is the signaling format for your FACCH. In this particular thing, we are going to have all the format has been divided into three parts. The first one is nothing but a flag, which carries only one bit, and this is used for the signaling purpose, signaling word header. As you can see here, you're going to address it as in 0 or 1. 0 represents the first word and 1 represents the subsequent word. And in this remaining 48 bits is allotted for the message or the content which we have been to be forwarded, and the last 16 bits will be allotted for an error detection. And here is the format for your SACCH. In this they're going to use a one for signaling and one for reserved one, that also allots for 1 bit each. And in this 48 bits will be allotted for the message and 16 bits will be allotted for the CRC. CRC is nothing but a cyclic redundant check. And this message structure actually contains the total message contains about five things should be carried out. So that one is your first one is your message type. Message an application message header. So the first one is nothing but your message application message header, which you can see at the first. And the second one is the mandatory fixed parameters. You can observe in the third place. And the mandatory variable parameters, remaining length, and optional variable parameters are the remaining one, which has to be carried by the all these five things going to contain in the messages actually. So now we are going to see about how the TDMA structure will be and the frame length and all that thing. Basically, in NA TDMA, the setup channels are analog channels shared with the AMP systems. One digital channel contains 25 frames per second, and each frame is 40 milliseconds long and has 6 time slots. Each time slot is 6.66 milliseconds long, and one frame contains 1944 bits, and it contains of 972 symbols, as you can see in this particular figure. Each slot contains 324 bits and of 162 symbols, and the duration between bits is 20.57 microseconds. Therefore, one radio channel is transmitted at 48.6 kilobits per second, but only 24,000 symbols per second over the radio path. So each frame consists of 6 time slots. The maximum effect on the signal for a forward time slot is 1/2 full symbol period, and for reverse time slot is 6 symbol periods. That you can observe here the overall length in each slot, what we have discussed earlier. In this, there are two frame lengths, full rate and half rate. Each full rate traffic channel shall use two equally spaced time slots of the frame. The overall length in each slot is channel 1 uses slot 1 to 4, and channel 2 uses 2 and 5, and channel 3 uses slots 3 and 6. Whereas each half rate traffic channel shall use one time slot of the frame. Channel 1 uses time slot 1, channel 2 uses time slot 2, channel 3 uses time slot 3, channel 4 uses time slot 4, channel 5 uses time slot 5, and channel 6 uses time slot 6, like this. So full rate uses 2 time slots at a time, but the half rate is going to use only one time slot at a time. And basically the channels. So in NA TDMA there are no common channels as they are used in GSM. That we have to notice it. And the digital call setup uses the 21 setup channels which are shared with the analog system. In this supervision of digital voice channel, the supervision channels in NADSM are similar to those in GSM. That's what we are going to repeat it here again. And that one of those things are fast associated control channel. That's what we are discussing about, is nothing but FACCH. What we have seen the frame structure also in the past diagram. So FACCH is a blank and burst. Already we have discussed that. Burst channel equivalent to a signaling channel for the transmission of control and supervision messages between the base station and the mobile station. It consists of 260 bits. Mostly FACCH is used for handoff messages. And whereas slot associated control channels, SACCH, is signaling channel including 12 code bits present in every time slot transmitted over the traffic channel, whether these contain voice or FACCH information. And we have one MAHO, it's nothing but mobile associated handoffs. So how the handoffs are going to happen in this? So mobile station performs signal quality measurements on types of channels. measures the RSSI, nothing but received signal strength indicator, and the bit error rate, information of the current forward traffic channel during a call. And the MAHO also measures the RSSI of any RF channel which is identified from the measurement order message from the base station. Basically, the MAHO consists of three messages. One is start measurement order, stop measurement order, and channel quality message. In the first one, coming to the first one, start measurement order message, it will be sent from base station to the mobile station, whereas coming to the acknowledgement message will send from the mobile station to the base station, the quite opposite way. And coming to the second one, stop measurement order, in the stop measurement order, the signals will be sent from the base station to the mobile station, the same as the previous one, but in this acknowledgement one, the mobile station to the base station. And the channel quality message, mobile to base only. So for this channel quality message, as we are measuring the quality of the message, the mobile transmits the signal quality information over either the SACCH or FACCH, because this is to measure the quality one. So these are the things about the TDMA. In the next video, we're going to discuss about CDMA. Thank you.